Hello guys, welcome back. So we are going to look at the list interface, which is one of the interface in the collections framework. So because the collection framework has a lot of classes, a lot of interfaces, we will just be picking the most frequently used ones. So under list, we will look at the array list and linked list because you are most likely to be working with these implementations of a list when you are doing your Java application. As we have seen in our previous lecture, that a list is actually a collection of objects, and it maintains the order of insertion, and you can have duplicates as opposed to a set which does not allow duplicates. So it's important for us to look at the differences between array list and a linked list. We will see that they do the same thing, but they do it differently. An array list uses a dynamic array as storage, whereas a linked list uses a doubly linked list as a storage. So linked list uses what we call node data structure. You have a node, next we have previous. So you are able to traverse a list. Then we see that a list interface, array list interface implements list. So basically it's a list. Whereas a linked list implements both a list and a deck. So this tells us that a linked list is both a list and a queue. And we know that a deck is a queue that is double-ended, that you can traverse from both directions. Then a list is slow because if an element has to be removed from the array, it means all the elements has to shift, their indexes have to shift. So that makes it a bit slower. But with a linked list, if you remove one element, you don't need to shift anything. All you need to do is to shift the pointer that for the element that comes before that element to point to the element that is after the element that we have just selected. It's like you saying node next. That's it. So that means now you don't need to do any of the shifting. So that is a performance advantage of a linked list over an array list. So we see that you are recommended to use an array list for storing and accessing elements. And you are recommended to use a linked list when you have to do data manipulation, because it's a bit fast. Deleting, adding, removing, and all that. Then we see that a list or an array list, when you create an array list, it normally gives you a default capacity of 10. But we see that a linked list is initialized without a default capacity. And then memory elements of an array list are contiguous. That means they are stored like one after the other. But in a linked list, we don't have contiguous memory. So let's just go into our code and see a list demo here. So this is an example that we have here. First, we have an array list, and second, we have a linked list. So as we said, that a list interface maintains order, which means the order of insertion when we print list should be 5, 4, 3, 2, 1. The same goes for the next list, which is linked list. So if I run this code, I should be able to get this data coming back to us. But I've already mentioned the differences between them. So you can do quite a lot with a linked list. I don't think it would be important for us to go through that, because that would mean explaining the entire API, collection API, which is not the intention of this video. The intention is to show you what it is and how you can be able to use this tool. So if I was to give you a conclusion, when you have a requirement to only be dealing with accessing of elements in your list, accessing and storing of elements in your list. You are recommended to use an array list. But if you are going to be doing manipulation of that data, like deleting most of the time, we are recommended to choose a linked list so that it will give you a faster performance. So that is it. So if we come to linked list 2, list demo 2, we see here that the way we are creating an array list for these two object or variables, list 1, list, and list 1, it's different. The first one, we don't give capacity. The second one, we are giving capacity. These two actually have big implications into the code. So we already know that when you say array list, you get default capacity of 10. Let's see, this is the default capacity, as you can see it, which means that your array will have the size 10 initially. And then what happens is that as you keep adding elements into the list, there's a time when your list will be, let's look at this add method. There's a time when your list will have to be grown, like increased in size. So let's look at the implementation, which is an array list. We see that this mod actually represents how many times a list has been modified. Then we are adding here. Let's see this add method. So what we are doing here, we are checking if the size of the list is equals to the element list. Like the size of the list is equals to the length of the the length of the list. So that means what is in the list, is it equals to the length of the list, which means the list is full. That is basically what this is checking. Is the list full? If that's the case, grow the list. And let's look at what grow does. Grow, you see that you will have to actually grow the list. There is a formula they use to grow the list that you have here. You can make a research about how that is done. That is not the focus of what we are doing now. The focus is that the list will be grown, and every time you grow the list, you create a completely new list, and then you give the new list a new length, and then you copy all the elements in the old list, you put them in the new list, and you return the new list. That's what grow method does. So from what I remember is that the grow, you grow the element by half of its size, something like that. So that means if you have 10, you would find that you grow it maybe by 5. That means the next size would be 5 or something like that. I'm not sure, but the growing algorithm says that. So now, if we look at this, if say you're going to have a list and you know that your list will store not more than 10,000 elements, it is recommended for you to pass it as a parameter to the constructor of the list. Why is that important? It is important because there will be no time when you will need to grow your list. It is fixed. There is never a time when the condition, this condition that we have here, let me just go there quickly. There's never a time when this condition will hold, because we see that when this condition holds, we are calling this grow method, and this grow method does a whole lot of things, which is time consuming. And imagine if you had to do that for every time you're increasing half, then you add, you take from the old, you put in the new, and you keep doing that when the element, when the newly created list is full. That is time consuming. So to avoid that, it's recommended that you use the initial capacity. if you know that the initial capacity will not be more than 10,000. In this way, you're avoiding that performance time that it takes to be creating a new array, a new list when your list is full, and taking elements from the old list to the new list.